the chief benefit to the microbes is the fact that it protects them. If they're inside our body in particular, it protects them from our immune cells being able to detect that they're present, which means that the immune system is only able to suppress their growth. And I'll come back to that in a moment. So in the context of the life cycle, let me just go into that. I'll come back to that in a second. So the life cycle, what we have is the surface adhesion. So the motile microbes are able to stick to a surface area. They
So
generally
the microbes always come from outside.
Generally come from outside, but they can also come from an existing biofilm.
Okay.
So this life cycle, if we have a look here where we get to maturation and dispersion from an existing biofilm, there's an opportunity at that point for the hosts to step in and actually filter the next cycle again. So the immune system is able to step in at this point and actually identify that those microorganisms are there. However, the immune system is not always capable of doing that because it can be busy with other pathogens, or there can be other reasons that the immune system is dysregulated, or otherwise the person is immunocompromised. So it's important to understand, going back a bit, that when we look at the mucosal tissue, there is a significant surface area available for these biofilms to form. So roughly 125 square meters, and there's not a significant difference between the male and the female physiology with regards to the opportunity for these biofilms to grow. So the largest area is actually the respiratory tract, and the second largest area is the gastrointestinal tract. And then there are minor mucosal surface areas listed in sex organs and other tissues. So it is really interesting as far as an opportunity then for different infections. If you could consider that every single time that you've been infected with these microorganisms, there's a possibility that they've set up a biofilm reservoir in the tissue where you're infected, or if they're translocated to different tissues, then they can set up a biofilm reservoir in other tissues.
And we don't notice that.
And we don't notice that because at that point, they're not triggering an immune response inside the biofilm. It's only when they come out of the biofilm that the immune system actually mounts an attack, which can be, the source of inflammation. But while they're inside of the biofilm, they still absorb nutrients and they still produce metabolites. And some of those metabolites are very toxic. So there can be endotoxins and mycotoxins, depending if we're talking about bacteria or fungi.
And these microtoxins, they go into the body. They don't stay in that film.
Correct. Unless, of course, you have probiotic species, which are nearby the opportunistic pathogens. And some of those probiotic species have a function where they're able to break down the biofilms, but also they can pick up the toxins and they can metabolize them into something that's not toxic.
Great. Mm-hmm.
However, if we don't have those probiotic species, that puts the load back on the host to actually metabolize those toxins.
Mm-hmm. And when you say that they extract nutrients, what does it mean? They are taking what we eat?
That's right. So they take the nutrients that we eat, but also that are circulating, because our body will also produce a number of things or catabolize it from tissues. And they will get the benefit from the nutrients, one way, whether or not it's something that we've consumed or whether it's something we're producing.
So they are actually feeding themselves what should feed our cells and our organs.
That's right. I mean, look, the probiotic, the helpful species do the same thing, but the major difference is that they're not producing a toxic metabolite. So what they're producing is more helpful for the host.